Everybody, in this video I'm going to give you a brief overview of how you should prepare for the Unit 3 exam. So let's start by talking about what topics are going to be covered. We are going to be talking about similar triangles and quadrilaterals. That was what was covered in Chapter 3 or in Unit 3. For similar triangles, specifically we talked about three postulates and theorems. The angle-angle postulate, the side-angle-side similarity theorem, and the side-side-side similarity theorem. Now, if you recall, I don't believe, unless I'm mistaken, I do not believe we had any examples for the angle-angle postulate. So you can really not worry about that one. We're not going to see that on the exam. You will see the side-angle-side similarity theorem and the side-side-side similarity theorem on the exam. So make sure that you have those written on your formula sheet and are familiar with those theorems and how to apply them. Now, speaking of formula sheet, so your formula sheet for this exam, it can be one piece of notebook paper or printer paper, whichever you prefer. And it can have writing on one side. Writing on one side. Alright, so what kind of stuff should you be putting on this formula sheet? Well, like we just mentioned, you should definitely put the side-angle-side similarity theorem and the side-side-side similarity theorem. I'm about to show you a couple of little checklists that you may want to add to your formula sheet as well for those two theorems. Then when we move on to quadrilaterals, you definitely want to know the definition of each one of those shapes. So you would definitely want to put that on your formula sheet. Any special properties that go along with those shapes, like I know there's a couple, I want to say there's 4 special properties for parallelograms, and then 1 for rhombuses, 1 for rectangles. So all of those should go on your formula sheet. And then in addition to that, you can put whatever you want on there. There's no restrictions. You can put examples. You can put questions from the practice exam. You can put questions from the homework. Anything you want to go on there is fair game for the formula sheet, as long as it can fit on one side. Okay, so side-side-side similarity theorem. I accidentally put these out of order, so on the last slide I put side-angle-side similarity theorem first, and then here I accidentally switched the order, so that was my bad. But for the side-side-side similarity theorem, we just had one thing that we had to check, and that is, are the sides proportional? Now you do have to check that for all sides, right? So there's going to be 3 sides of each triangle. So let's say this is like ABC, triangle ABC, and then let's just say DEF, triangle DEF. So specifically what you're checking is side AB congruent to side DE, or excuse me, not congruent, but proportional. Let's write that differently. Is side AB or line segment AB proportional to DE? And then additionally you would do BC. Is that proportional to EF? And then lastly, is AC proportional to, let's see, that would be DF. All right, so basically you're just checking to see, are all those sides proportional to each other? And the way that we did that was we set up proportions. Proportions are where you have a fraction equal to a fraction. And the way that I was doing it, let's say that this was like 2, 5, 10, and this was 16, 20, 50. Right, so I totally just made those up on the fly. These are probably not proportional. But the way you would do that is I always did the triangle on the left became the numerator, the triangle on the right became the denominator. So you would do something like 2 over 16. So again, that's coming from here, AB and DE. Is that proportional to, remember we put the little question mark on the equal sign because that's what we're checking. We don't know that these are equal, we're checking that they're equal. So we got AB over DE, let's do BC over EF, so that was like 5 over 6, excuse me, not 16, 20. 5 over 20. All right, and then you would cross multiply to check that. All right, so just to show you, you would cross multiply here. 20 times 2 is 40. Again, we don't know that these are equal. 16 times 5, what is that? That's 64 plus, let's see, 64 times 5, 320. Whoa, did I type that in right? Let me check. 16 times 5, 80. Whoa, I don't know what I typed in. My bad. All right, 16 times 5 is 80. So those are not equal, so those are not proportional. So you would say triangle ABC is not similar to triangle DEF. All right, so pretty simple to check that those are equal. You're really just setting up a bunch of proportions and doing cross multiplication to check that they're equal. The side angle side similarity theorem is actually a little bit easier, in my opinion, to use than the side similarity theorem. So the first thing that you have to check for side angle side similarity checklist is, are the angles congruent? And here congruent just means equal. So you want to check and make sure that the angles are equal. And then here you're just going to have two sides that are labeled since it's side, angle, side. So two sides, one angle. You're going to check and see, are the two sides proportional? And then that's all you have to check. So side, angle, side, in my opinion, a little bit less work than the side similarity theorem. Oh, and before we move on from this topic, let me just remind you that the symbol for similar is that little tilde. So that symbol means is similar to. So the way that we write that is we do something like triangle ABC is similar to triangle GLK. Okay, so that symbol means is similar to. All right, moving on to section 3.2, we were talking about parallelograms. A parallelogram is defined as a quadrilateral where both pairs of opposite sides are parallel. Remember, a quadrilateral is just a four-sided figure. All right, so a parallelogram is a four-sided figure where both pairs of opposite sides are parallel. All right, so this is the symbol for a parallelogram. And again, saying that both sides are parallel here. So that means that this top side is parallel to the bottom and the left is parallel to the right. All right, next let's look at our special properties of parallelograms. We had 4 special properties. We didn't really use this last one, so I wouldn't worry about putting that one on the formula sheet, although it's not going to obviously take up that much room. But we did use the first 3 properties. So the first property says opposite sides of a parallelogram are congruent. All right, so the opposite sides have the same length. Similarly, the opposite angles are congruent, so the opposite angles are going to be equal. All right, and then lastly, the consecutive angles of a parallelogram are supplementary. All right, remember what supplementary meant? I actually have a typo here. I'm just going to fix this on the fly. Here, not congruent. Let me do a different color there. Try to get that away. They're not congruent. They are supplementary. Remember, supplementary means they add to 180 degrees. Consecutive angles, when we're talking about parallelograms, consecutive angles are going to be angles that share a side. All right, so if this is A, B, C, D. Then A and B, those are consecutive because they share a side. Let me change the color. B and C are consecutive, they share a side. C and D, whoa, just totally made that go away. All right, let's just do like this. These two, C and D, are supplementary, they share a side. And then A and D are supplementary, they share a side. Or consecutive because they share a side. All right, so that means that A plus B has to add to 180, B plus C has to add to 180, C plus D has to add to 180, and then A plus D has to add to 180. So the two angles that share a side are supplementary. Very useful property. All three of those are. All right, a rhombus is defined as a parallelogram with 4 congruent sides. That means all 4 sides have the same length. All 4 sides have the same length. All right, so rhombuses, if you look at a question, okay. I got cut off there, but if you look at a question and it defines something as a rhombus, if it defines a diagram or a shape as a rhombus, then you know that that means that all 4 sides have the same length. Now, similarly, if you have a shape or a diagram and it is defined as a rectangle, that means that you can assume that all 4 angles within the rectangle are right angles. All right, so all 4 of your angles within this shape are 90 degrees. So each one is 90 degrees. And then sort of combining those two shapes, rhombuses and rectangles, a square is defined as a parallelogram with 4 congruent sides and 4 right angles. All right, so not only are the sides all congruent, the angles are all congruent as well, and they're all 90-degree angles. All right, and then the last thing I want to mention to you is just the special properties of rhombuses and rectangles. So the first special property has to do with rhombuses, and the second special property has to do with rectangles. The special property regarding rhombuses says that if a shape is defined as a rhombus, its diagonals are perpendicular. Now, what does that mean? That means they cross at a 90-degree angle. All right, so the diagonals of a rhombus cross at a 90-degree angle. And then our last special property of rectangles says that a parallelogram is a rectangle. So if you're given a problem and it's defined, this shape or diagram is defined as a rectangle, then you can assume that its diagonals are congruent. All right, so that means that if you draw a diagonal through each corner, that those two lines are going to be congruent. Right, so if this is A, B, C, D, then you could say that AC is equal to BD. So the length of the line segment AC is equal to the length of the line segment BD. All right, if you have any additional questions, please let me know. You can all view the answer key for this practice exam. I've got it uploaded to D2L, and that way you can go ahead and check your work. You can see all the problems worked out step by step. But if you have any additional questions, please shoot me an email and I'll get back to you as soon as possible. Thank you.